Hey everybody, welcome back. In this sequence of videos, we are going to introduce slope failure. And for the rest of the semester, we are going to be talking about slope stability analysis. And so we're going to start out by just talking about what are the basics of a landslide, of a slope failure. What conditions cause that, talk about different kinds of slope failures, and just look at some really interesting cases of landslides, both large and small, that have occurred. And so let's kick things off. There are different kinds of slides that occur. And almost all of these have to do with saturated soils. It's possible to have a slope failure in a dry or partially saturated soil, but most of the big ones, most of the interesting cases, and typically the critical cases involve wet soils, either fully saturated or mostly saturated. And if that saturation builds up over a long period of time, that leads to slow-moving, deep-seated slides. But if you have really intense rain and the water builds up very quickly, you can get shallow, fast-moving slides, and these can cause a tremendous amount of damage, especially because they occur suddenly and it's hard to get people out of the way, and they can be quite violent. Actually, we'll show some cases of that. Sometimes the slide starts downhill and progresses, the sloughing of the soil and the movement progresses uphill. That's called a retrogressive slide. And sometimes they start at the top and move down, and that's called a progressive slide. So here's just an interesting series of illustrations of different kinds of slides. A rotational landslide. This is the most common, I dare say. When we're dealing with dams and levees and cuts adjacent to highways, or a cut or an embankment next to a development, most of the cases that you would be hired as a geotechnical engineer to investigate involve rotational landslides, and that has this, we call it a circular surface. It kind of rotates. It kind of spins, turns like this, and dumps out. And we'll deal with a number of mathematical techniques to simulate this. You can also have a translational slide. We'll learn how to simulate these as well. And this occurs when you have, maybe as shown on this diagram, a thin, weak seam parallel to the surface, and so instead of getting the circular surface, it just kind of slides. Sometimes it slides as a block, as shown in C, especially if you have like rocks. You probably noticed rock falls. Those occur often near highways. Sometimes an entire section can topple over. We won't be dealing as much with rock falls or topples. And sometimes you can have a debris flow, so you get this intense rainfall up in a canyon or on a hillside, and then a slide occurs, and it's just this big, long, muddy debris flow. Those can cause a lot of damage. We'll see some examples of that. A debris avalanche is kind of the same thing. An earth flow, this would be sometimes when an earthquake occurs, an earthquake, it triggers something called liquefaction, where the soil actually liquefies, and it doesn't even require an earthquake per se. Certain types of saturated soils, once they begin to move, they turn into liquid, and we'll learn about that. We'll show some examples of that here coming up. Creep, sometimes slides occur very slowly over long periods of time. I can think of, there's an example up Provo Canyon here, just north of Brigham Young University. Just below Bridal Veil Dam, there's a big section of an area that was slowly creeping down toward the highway. They've got some homes built up there, and it's a classic case of long-term creep. It used to be that the highway would bulge occasionally because of this slow-moving landslide, and they'd have to go in and fix it. And a lateral spread is just another type of lateral flow. This also often occurs due to liquefaction. It's the same with an earth flow. So that's just a kind of overview of a number of common types of slides. So the deep-seated slides, remember these occur, this would be the rotational slide. Most predominantly, you can get some of the others as well. And this occurs when you have a slow, gradual rise in the moisture content, or maybe a change in the loading conditions, which we'll talk about a little bit later in the video. So this is a classic rotational slide, what it looks like. Just a few terms here. This where it rotates here, this is called the shear surface. The bottom part of this is called the toe of the slide. The upper part is called the head. These exposed faces after it rotates are called scarps. You have the main scarp at the top. You might have some minor scarps. And then, you can have, some of these are just less common. You can have a number of fissures in different places. But though the toe, the head, the shear surface, the scarps, those are the primary terms we want to remember. So let's look at just a few images of different kinds of slides. This is a coal mine in Australia. You get a lot of slope failures in mines because there's an incentive to make it steep embankment to get at the ore, and they try to cut it close to the edge as they can, and sometimes it gets out of control and they get a slope failure. And these can create a pretty big mess. But often they can afford to deal with a little bit higher risk because, it's not like you have homes down here. You could potentially trap some miners underneath this if it's fast moving, but these are fairly common. This is a slide that occurred in Taiwan in 2010 that got a lot of international attention. It occurred fairly rapidly, so rapidly that it buried 3 cars on this highway. And so there were some fatalities. It was a pretty big slide as well. And of course, it took them quite a while to clean that up. This is another famous slide landslide in California, the La Conchita landslide. It occurred between Santa Barbara and Ventura, California. I actually saw a presentation on this, and there was, as you can imagine, there was some litigation that occurred because of this. I can't remember the exact term who was sued, but somebody was sued. So this was right next to a community, built next to a steep hillside. You got to understand, when you build a home right next to a steep hillside, you are assuming some risk. And maybe after taking this class, you'll look a little more critically at some of the building lots you might consider in the future because of this. This slide damaged 36 homes and killed 10 people. So sometimes the consequences can be pretty severe. This is an example of a slope failure in a landfill. This landfill, they were filling it in stages and filling it in from this side. And one day, all the waste in the landfill created a landslide, and it looks like it went out. And if you go back to the before, you'll notice that there's some. This doesn't look like a lined landfill to me, and because it's kind of black and white, it may have been a landfill that was used before the current standards and requirements for using a liner with a leak detection system or a leachate collection system. But anyway, you notice down here there's a road and this looks like an unprotected part, and that got covered up, and so that looks like a mess to clean up, literally. This is another really famous slope failure. This is the Lower Van Norman Dam in California. In 1972, there was a Loma Prieta earthquake. It was a very large earthquake. I can't remember the exact magnitude on the Richter scale. But what was interesting is there was this reservoir, and they had a big slope failure on the upstream side. So they had this underwater slope failure. So you can't see the slide. It's underneath the water here. But it left an 18-inch crest on the dam holding the water back. It came razor close to failing. Had another 18 inches of that slope slipped into the water or slid away, that water would have started cresting the dam and eroding it, and very high likelihood that the dam would have completely failed. And I believe it was during the nighttime, and there were 100,000 people living directly below the dam. And it's really hard to evacuate people at night. So basically, this could have been a massive, massive disaster, and they narrowly escaped that. And because of that, there's a lot of standards and policies changed on earth dams to make them more resistant to failure during an earthquake. This is an interesting one. We now have very high resolution imagery from Mars, and it turns out there are a lot of really, really big landslides occurred on Mars. I mentioned earlier, most slides occur when you have water. There hasn't been a significant amount of water discovered on Mars, but they still have some rotational slides. And so you can see the scarps here, clearly where the soil has sloughed away. And these are massive slides. The scale of these is huge. And so here's another diagram showing a series of slides on the surface of Mars. And somebody had an interesting time researching that. In 2014, there was a very famous slide in Oso, Washington, and about 10 million cubic yards of soil sloughed off, and 30 homes were destroyed. There were 43 fatalities, so as landslides go, this is a very serious one. And what made it so deadly is how fast it moved. They later pieced together information and figured that this slide moved almost a mile, and it traveled at 40 miles an hour. So there was just, people saw it coming, but there's just no getting out of the way. And this is kind of a before and after satellite photo. This is the area that slid off. You notice there's a river that goes through here, and in this previous slide, this river is, this bottom part of the image here is the upstream side, so you can see the dam caused some ponding on the upstream side. But so what happened is it occurred in two stages. First, a lower segment of the slope gave way, followed by progressive failures of the upper slope. And as the upper block gave way, it produced large compressional forces, causing an undrained loading condition for the lower block, and it subsequently caused liquefaction. This thing I talked about before, with certain soils, when you shake, they turn into liquid. And this led to rapid mobility of the soil. And 40 miles an hour, that for that much soil, 10 million cubic yards, that's a pretty serious case, and hence all the casualties that occurred. I don't have a lot of detail on this one. This is a slide that occurred in 2001 in a subdivision in Utah. Just got really wet soil, and the whole, this is at the top or the head of the slope. Obviously, you can see the scarp there. And there are a number of, I can point to some places that occurred something, that experienced something like this up above campus in Provo, Utah. Up on Mile High Drive, there's a place that looks just like this, and you can see damage on the road. And there's a number of homes that have had a lot of damage that had to be fixed. Not as much movement as this, but same kind of slide. In 2015, the Bingham Canyon Mine, which is again north of us here in Utah, the largest open pit mine in the world, they had a massive slope failure. And it occurred very rapidly. It was really a miracle that nobody was killed, because normally there are a lot of trucks down in the area where it failed. There's also this thing right here I'm pointing to is a visitor center that you used to be able to go to the mine and look down in the mine. That visitor center was completely carried away. Hard to overstate the magnitude of this. 165 million tons of dirt. That amount of dirt could fill 19,000 miles of rail cars and stretch 3/4 of the way around the world. And it actually was measured at a neighboring seismograph station. It was also the largest landslide in modern history. And so here's another picture. All of this material up here sloughed down and filled in the mine. You'll notice there were some trucks that were buried miraculously. No humans were buried in that. And so what did they do? They just spent the next couple of years digging that out, and they've pretty much recovered from it at this point, but that was a pretty serious setback. This is another local earthquake that was kind of interesting. It was near a new subdivision in 2014. They had an engineered slope here at the edge of the subdivision. It was originally been part of a gravel pit, but they did some earthwork there, but then this slid down. This is some LiDAR images of the slope, but as you can see, it came down, and this was a tennis court on the right, a covered tennis court that you can see right down here. Clearly, as shown on the left, it destroyed a few homes, but I don't think there were any casualty or loss of life in this one, but it got a lot of attention.